Welcome to Prince Maths Clinic, the e-learning solution at your pace and time.
Good day and welcome once again to class. We have this wonderful set of integrals to solve. The first one says we should integrate 2x plus 1 all over the square root of x squared plus x plus 4. When you want to attempt integrals like this, watch out for the particular concept I'm going to explain. Whenever you can differentiate the denominator of an integral that is fractional in nature, that gives you an item that is on the numerator, then it means that you can go ahead with use substitution. Let us look at what I've just explained. Write out your question. In the previous class, we talked about using substitution method. I'll also be using the substitution method here. But watch out to find out if what you differentiate here will give you an item in the numerator. So therefore, first of all, I'm going to say let u be equals to what I have here, which is what? X squared plus x plus 4. Therefore, if I differentiate u with respect to x, du over dx, if I differentiate this will be 2 times x, then take away 1 from the power, it will be raised to the power of 1. And since x raised to the power 1 is still x, I'll leave it as 2x. Then if I differentiate x, the power here is 1. 1 times x is x. Then 1 minus 1 will give me 0. And anything to the power of 0 is 1. So this becomes 1. You can see what I just explained. After differentiating what I have here, I obtained what is in the numerator. So I will say it again. If the numerator is a derivative of the denominator, it's a perfect reason to use u substitution. Let us go ahead. Therefore, I want to make dx to stand as the subject so that I can replace it here. Therefore, my dx will become what? Du all over 2x plus 1. So I can substitute back into this particular equation by replacing this and this. Therefore, the integral 2x plus 1 over square root of x squared plus x plus 4 dx will become integral of 2x plus 1. Everything. Remember, we said everything is u. So this becomes square root of u. Then dx now is now du over 2x plus 1. So put it here. Du over 2x plus 1. Therefore, 2x plus 1 cancels out 2x plus 1. What do I have left? I have 1 over square root of u, then du. Mind you, I've not integrated yet. I've only simplified what I have. Now I want to integrate. This can be written as 1 over u to the power of half. Remember, when you have 1 over x, let us say x squared, it can be written as x to the power of negative 2. This negative talks about division. Good. So I'm going to say equal to the integral of u to the power of negative half, then du. Now I can integrate. If I integrate this is what I'm going to have. Remember, u to the power of negative half. Add 1 to the power, then add up what you have in the what? Power. 1 minus half gives you what? Half. Therefore, this becomes u to the power of half, everything over half. And if you further simplify this becomes u, because this becomes 1/2. When you solve that, you are going to get it as 2, right? Then you have u to the power of what? Half. At this point, you need to substitute your value for u. Therefore, it's now 2. Then what did you say? You call this your u. This become what? X squared plus x plus 4, all to the power of 1/2. Or your result becomes 2, because anything to the power of half means square root. This becomes square root of x squared plus x plus 4. Then, because you have integrated, you need to what? You need to what? Add your constant plus c. So this is the result to our question. Then let's look at the second question. Again, we have a situation where differentiating our denominator will give us an item on the numerator. So using u substitution will be a good idea in this instance. This is called your lower limit. This is called your upper limit. Right? At some point in this question, we are going to use these limits. But the first thing we need to do is let's substitute. Let u be equals to what you have in the denominator here, x cubed plus 1. Such that if I differentiate the u with respect to x, it will be 3 times what we have here. So it will be 3x, then 3, then take 1 from the power. So 3 minus 1 is 2. So I'll write it as 2. 3x squared. Then if you differentiate a constant, you get 0. Therefore, I want to make the x the subject so that I can replace it here. Therefore, the x will now become what? The u over 3x squared. Now you can see the goal. I've gotten an item in the denominator that can cancel out my numerator. Hence, this integral is now my x squared will come over this, now becomes what? Everything there is u times the u now all over 3x squared. Now x squared here, we cancel out x squared here. So therefore I have what? This now to be 1 over u. Then remember, I have 1 over 3 here. Then I have the u. And remember the rule I gave you. So I'll pull out this constant, which is 1 over 3. Then my upper and lower limit. Then I have 1 over u du. So this is what I have. Now, when you integrate 1 over x, it is a standard integral. Please don't make the mistake to write it as x to the power of negative 1. Right? Now say plus 1. If you do that, you remember when you say minus 1 plus 1 in the denominator, you get 0. It's going to give you what? Error, math error, or infinity, which will make your work that you have been doing so far invalid. But rather, when you integrate 1 over x, it's going to give you ln x. Or better still, you can write it as log x in base e. They have the same interpretation. Now that we have this as 1 over u, the integral will be what? Ln u or log u base e. Good. Therefore, integrating this to become 1 over 3, if we integrate this, this becomes what? Ln u, putting your limits 1 and what? 0. Right? Therefore, we can now simplify. Remember that our u is what? X cubed plus 1. Then it has an upper limit 0, 1. So what does this mean? It means putting your upper limit. What's the upper limit? 1. Then it's cubed plus 1. Then minus, right, your lower limit, which is what? Ln x now is now 0, cube it plus 1. Therefore, this becomes 1 over 3 ln 1 cube is 1 plus 1 is 2 minus 0 to the power of 3 is still 0 plus 1 becomes what? Ln 1. Ln 1, right, is what? Is 0. Therefore, we can report our result like this. 1 over 3 ln 2 minus 0, because natural log of 1 is 0. So this becomes 1 over 3 ln 2, or you say 1 over 3. Remember I said ln means log to base e, right? Which is log 2 to base e. And if you like, you can take this based on the laws of logarithm that says if I have log a base b, then this is c. This can become log a base b carrying what? The power of c. So you can replace this. You can say this is now what? Log of 2 base e to the power of 1 over 3. Either of these will be correct. So this brings me to the end of today's class. I hope the solution was helpful. Kindly like this video, share it with your friends and colleagues. Also, subscribe to this channel if you have not done so, and encourage others to subscribe as well, because in this channel we consider lots of questions in mathematics that cuts across all kinds of mathematics, from international maths challenge to SSC questions to UTME questions and the likes. Even we consider Olympiad questions as well in this channel. So stay glued to this channel and you get the best from us. Bye for now.